beautiful people. Hi. Welcome for a new CodamX session. And believe it or not, but today we talk about you, about your brain, right? We talk about a programmer's brain. How does it work? How can you actually become more efficient? How can you actually share your knowledge with the others? How you can teach your knowledge to somebody else. And there is no better, speaker than Felienne Hermans to actually give this talk, because Felienne is an associate professor at the Leiden Institute of Advanced Computer Science, where she's actually focused on the programming education. She also teaches at VU computer science teachers how to teach. Right? She is the creator of Hedy programming language. She is the founder of the Joy Coding Conference. She was also awarded the Dutch prize of the ICT. But the most important thing, I think, is to mention that we are very humbled by the fact that Felienne has been joining us 2 times now. We had conversations with her 2 times about how we can improve the piscine model so that, we have bigger success rate in terms of like how many students actually succeed from the piscine, especially when we talk about diversity. So from the bottom of my heart, I would like to thank you for that. We are actually taking this forward within the Bocal. Hopefully you're going to hear more soon about it. But yeah, I think this is a very brief introduction, and it's not about me and how we as the Bocal staff actually find you amazing, but it's more about you sharing your knowledge with us. So take the stage, Felienne.
Thank you. Thanks for the warm welcome. So I'm here today to talk about my research. I'm associate professor at Leiden University, where I lead research programming education. And then some people think that that's because I have a background in education, but actually I don't know that much about education, or at the very least, I didn't know that much about education about 10 years ago when I started to teach programming to children. So I started to work on Saturdays in a community center in Rotterdam, where I lived at the time, and there was a group of kids and they needed a programming teacher. So I thought, this will be easy. They are small children. These were 10, 11, 12-year-olds. How hard can this be, right? I know a lot about programming. I had just finished my PhD in software engineering. So I thought, this will be easy. Of course, children, I can teach you programming, because how difficult can their questions really be? They were so tiny. But as I said, I didn't really know that much about teaching. And what happened is that sort of subconsciously, I started to think back at how I learned programming when I was a kid. So this is me when I was about 10, learning to program behind my dad's very, very big computer. And when I learned programming, I didn't really have a programming teacher. There wasn't an adult to teach me programming, because this is like end of the 80s, early 90s. There weren't so many adults that knew programming. So there wasn't really someone that could teach me programming. Then how did I learn programming? Well, I learned programming mostly from books. So I'm so old that I took a physical book from a library, and this is how I learned programming. This is one of the books that I actually had, that I owned, that I learned programming from. And these books were allegedly meant to help children, teenagers, learn programming by introducing them to programming games. And then you could think maybe such a book, it would contain explanation. This is a for loop and this is a while loop. This is how variables work. But it wasn't like that. If you would open this book, this is what it would look like. So I am so old, this book did not come with a floppy. This book did not come with a CD-ROM. You just manually had to type all of those basic listings into the computer to get it to work. And this is, so I'm not a native speaker of English. I guess you can hear that. I'm Dutch. So I didn't even know what all the words meant, right? So it says next and print and velocity. I had no clue. So just typing everything in until I had games. But also, I had no internet, so I had no Steam. So there was no other way to get computer games on my computer than do this. Right? So this is how I learned programming, mostly without a teacher, without going to a programming lesson. And this is not just me. Actually, many people my age, people that are now in their 40s, like children from the 80s, they learned programming in this way, because there just weren't programming lessons, there weren't programming clubs, so you had no other choice than to learn programming this way. And this results in a culture in which many people like me that start to teach programming replicate this experience, not necessarily fully conscious, but it's just sort of, yeah, this is how I learned, so we will do that also with the children because it's probably fine. And you can see that culture very much if you look at programming books that you can buy today, so not in the 80s, but literally today, in shops, programming for children's books. I have a few examples. The examples will be in Dutch, but there's an English translation underneath. So if you look at programming for kids books, you see this is written by people that had my upbringing, right? So here's one. The best part of programming is finding mistakes. This is a story of a person who was like, oh, I just copied 1,000 lines of code manually. That was fun. Now let's look for some mistakes. Right? It's sort of a weird view. Right? Like, I love programming. I program every day, but is really the best part of programming finding mistakes? Like, half of the time, I am the person that put in the mistake, right? So I don't love finding mistakes. It's a certain view on programming, and for some people, it might be true that they find finding mistakes the most fun, but there are other things also that can be most fun. Saying that this is most fun, it says something about our view on programming. Here's another one. Programmers only learn from making mistakes. Yes, this is true. I only had a book. The only thing I could learn from was mistakes. But would I have had a teacher to explain things to me? Maybe that would have also been a great source of learning, right? But I had no teacher, so yeah, I sort of could only learn from mistakes. There just was no other way, but that doesn't mean there cannot theoretically be another way. Here's another one. This is really like good marketing for programming. You will fail often, and it will be frustrating. But so like, your first impression might be like, yeah, that makes sense. You know, programming is hard, and it will be frustrating. But also think of other things we market to children. Like you see by the visuals of the book, this is for like 10, 11, 12-year-olds. Imagine picking up a book about horseback riding. Will it say, you will fall off your horse often? Well, that's probably also true, but we don't really market the hardness of horseback riding. Or soccer. Oh, if you go play soccer, maybe you will lose 30-0 from a bit better team, right? That's also something that will happen that is painful, but we don't market those things. With sports, we are more likely to say, of course, you know, if you practice a lot, you can get better. So putting this in a book for children is really something, right? It really says something about our culture. Here's another one. Never be afraid to mess around and experiment. Again, like, yeah, that's the thing I did, but I had no other choice. This snippet is really a wealth of interesting quotes because the next line says, break the rules. So I think, now, I like break the rules as life advice. I like not following the rules, but is this good advice for programming? Really? You know what programming language this book is about? Python. This is from the same book. So it says like, break the rules, but also, this is Python. A colon goes there, a quotation mark goes there, a rectangular bracket goes there. Not a round bracket, not a curly bracket, not a triangle bracket. It has to be that thing, or the computer will go totally bananas. So break the rules, but also there's this special set of rules that you shouldn't break. This is confusing. And then, here's one more. Most importantly, it's fun. Most importantly, it's fun. And sort of, I mean, I don't hate fun. Like, it's not like, oh, I hate fun. However, emphasizing fun is also an interesting view on the culture of programming because there are many other good reasons why you might be interested in programming. Some kids are interested in programming because it's a really good career. It's a sort of an easy way to make 100,000 euros a year that will not get you dirty and you can work from home, right? This is a good reason to like programming. Other reasons could be that maybe you really care about, I don't know, gender inequality or climate change, and you think that programming could be a tool to improve the world. Emphasizing, saying that the most important thing is fun also is only a very small view, and this is true for Felienne-like people that are like obsessed with programming and think, oh, puzzling and mistakes. But it's definitely not true that programming is necessarily only fun, and I wouldn't even say, even though I love programming, that the most important thing is fun. This is also a very, very narrow view on programming. And I think it's important that you sort of realize the culture of teaching in programming because I'm pretty sure, also judging by the nods and the laughter, that you have also seen and maybe even said these things to other people. As I said, this is a culture that isn't just me, that's very, very common. We actually did a research together with a colleague in which we asked programming clubs worldwide about their practices. And we found that 71% of programming clubs worldwide have students work on their projects independently. So very much like I learned myself, this is also how I taught. I said, hey children, welcome to programming club. Here's printed out, well, it wasn't BASIC, it was Scratch and Python. Here's printed out programs. You just copy them into the computer. And if there's a mistake, well, the compiler is your friend. It will tell you if you're wrong, and then it will give you proper feedback. Have fun, children. If you have a question, let me know. I'll be sipping coffee in the back of the room, feeling really good about my participatiesamenleving. I am helping the world around me. Ain't I doing great? So this is very much how I was running this club. And of course, I didn't realize back then that I was setting myself and the children up for failure. I really thought I was sort of doing the best thing because it was just the only view I had. So I did focus on concepts with the children. Of course, I said, oh, programming, what's important? Algorithmic thinking and problem solving, like loops, you can repeat something. I very much focused on big concepts. I very much not focused on, hey, child, it really, really, really matters where the colon goes in Python or the compiler will be angry. Because I thought, they will figure this out. It sort of naturally comes from an error message that will be friendly. It probably will say something super helpful like unexpected EOF syntax error. So this will be okay, right? Unsurprisingly, it was not okay. It didn't really work very well. The children were really, really struggling. And I also thought, this is on me. These were children that voluntarily came to the community center on their free Saturday to take programming courses. So I couldn't say, they're not motivated, it's just totally my fault. And at this point, sort of my scientific curiosity kicked in because I thought, well, this is not my research area. My actual research area is designing programming languages. But this is interesting. Someone must have written a paper about this. And this was actually true. So I found this very interesting paper that had looked at users in Scratch, which is a visual programming language for children. You can say even sort of simpler than Python because it's like Lego blocks you click together. And what they found was that there was really, really high dropout. So many children, they create an account on the website, and then after a few times of programming, they just don't come back. What they also found, and this was really, really interesting, is that the children initially gained some skill in programming, but then their skills sort of flatlined. They didn't learn any new concepts anymore. So it was certainly not the case that over time they learned new things. It sort of, and then it flatlines. And then also children didn't get more efficient. So you could say, well, they're not learning new concepts, but at least maybe they're building bigger programs, they're getting more efficient. And that also turned out not to be true. So there was really this sort of plateau where kids were just forever. And I thought this is like exactly what's also happening in my programming club. Initially, of course, they learn a little bit, and then they just don't seem to advance anymore. And I really, really didn't know why. And at this point, I was like, well, I don't know anything about teaching, but I could learn more about teaching, right? I need to learn more because I need to do better. And it's sort of interesting because then for 2 years, I didn't do my actual job, which led to me almost being fired from my actual job because I was obsessed with this idea. And then sort of later on in my career, it all came together. But I really got obsessed with this. I was like, I need to know, how does knowledge from my mouth go into someone else's brain, right? This is possible. There exist people on this planet that are able to explain something to someone. I need to understand how this goes. So I really, really dove into how to teach, and specifically I looked at teaching of other school subjects, specifically math and language. These are also very hard concepts, right? The idea that you can simply just read these letters in maybe not even your own natural language. This is fantastic, right? Your brain is capable of magic. How do we do this? So I learned a lot about history and philosophy of teaching. Specifically, that there are different ways that people look at teaching and at learning. If you look at language, there's this very famous battle, some people even call it a war, it's maybe not the most appropriate word, but that's what people use, between two different approaches in teaching. One of the approaches is called phonics, and the other approach is called whole language. And phonics, for the Dutch people, this is what we call hakken en plakken. Right? This is probably what you learned when you were in groep 3. read, book. So the idea of phonics is that you spell out individual letters. And if you spell out the individual letters, and if you practice that a lot, you can then read bigger and bigger words. So it's very much start with the basic building blocks and then combine them into bigger words. The other side of the argument says, no, if you make children focus on a lot of practice, then they will get bored and they will not like this. So what you should do is you should embrace the whole language, because kids want to learn. You should just focus on what they like. The most extreme form of whole language teaching, it's not really so common in the Netherlands, is that teachers, they just give children a pen and then the children just start writing. And this, of course, this is not an actual alphabet, they just do random things. And then the teacher says, oh, what does this say? And then the child says, a unicorn lives in the forest. And it doesn't say that, it's just like, Vroom. But then over time, slowly, they all evolve to the same alphabet. And people that are sort of in this school, they say, well, this way we keep the enthusiasm of children for writing. We don't force them into boring practice. In math, you have a very similar discussion. In math, you also have these two sides that are very similar, where one side of the math education camp, they say, well, if children need to know math, they just need to know a lot of basic blocks. They need to know 1, 2, 3, 4 until 10, and they need the tables of multiplication, and they need a lot of explanation and a lot of practice, and then from that basic building blocks, they can build bigger calculations. This is the way most people my age and older were taught in elementary school. The other side of the equation says, no, if you focus a lot on boring practice, children will hate math. That's wrong. What you should actually do is focus on exploring realistic problems and problem solving. So people that grew up in the Netherlands that are a little bit younger than me are probably taught in this way a little bit more. So these are things like, Harry goes to the supermarket and he needs 5 eggs and 2 apples and 500 grams of flour. And he also has a bonus card which gives him 20% korting. So then what exactly is the price in the kassa? So this is the type of problem-solving math that, judging by the laughter, people are a bit younger than me actually saw in school. So this is typically math that focuses on application and on problem solving. People that don't really like this form say that this is also a bit of a mix of math and language, because you also have to have quite high reading skills to figure out what actually the problem is. Having read about those two debates, I thought this is interesting, right? So there's sort of some truth in both sides of the argument. I can see both sides. Why don't we have a fight in programming? Like, where's the both sides in programming? We don't really have this pedagogical debate because sort of everyone is on that side. Everyone is like, oh, let's kids explore and let's do problem solving. Why? This is weird, right? You would suppose that these type of people would also exist in programming. One of the reasons for this, there are various reasons, but one of the reasons actually is that programming education is quite rooted in a certain philosophy, which most people don't know, but I will tell you about a little bit. So there's the start of programming education started a very long time ago, in the 1950s and the 1960s, with a programming language called Logo, which is the origin of all the programming languages that also have a turtle, where you have a turtle that goes forward and turning. That actually comes from the programming language Logo. Anyone know the name of the creator of Logo? Doesn't mind if you don't. So the creator of Logo was Seymour Papert. He was a South African mathematician that spent most of his career in the US working at MIT. He was a mathematician, but he actually studied with one of the most famous psychologists of the last century called Jean Piaget. And Jean Piaget is the founder of an educational theory called constructivism. The idea of constructivism at its core is that you can't really put knowledge in someone's brain. The only thing Piaget says is for a person to be able to do is construct their own knowledge. You can never explain something to someone. It should always be constructed. Piaget said about Papert, nobody understands my work better than Seymour. So there was a very strong philosophical connection between the creator of programming education and someone that said, basically, you shouldn't explain too many things. And this is a very famous quote by Seymour Papert. He says, by explaining something to someone, you take away their opportunity for a child to discover it. Right? So it's never really good to explain something like what is a variable or a colon goes at the end of the line in Python, because now I've stolen something from the child that is the opportunity to discover it themselves. So you see that programming education, seemingly neutral in didactics, has a very, very strong leaning towards a certain way of teaching, which is this exploratory teaching. And it's interesting that you are all not aware of this history, and most programmers are not aware of this history. However, many programmers buy into this ideology without really knowing where it comes from. And if you look at this, it sounds great, right? Oh, it's so great, discovering something. You shouldn't spoil children. They should get their own experience. But if you look at other things, we don't really let kids discover the alphabet or let kids discover math. It's just not so efficient. And even out of school teaching, right? So sports or music, if you have a child and they want to learn to play the guitar, you bring them to a tutor and the guitar tutor says, hey child, welcome to guitar lesson. Here's a guitar. This is interesting, thank you. How does this work? I don't want to spoil the surprise, friends. You just do, does it sound nice? If it sounds nice, this is not very effective, right? And the same with tennis lessons. You expect a tennis teacher to say, these are the rules, this is how you hold the thing, because it's just not very effective, and it's very likely you will teach it to yourself in a wrong way to grab the racket or to grab the guitar. You want a teacher to explain the basics, and you want to practice the small basics before you can do something like creativity. So you see all these sides sort of look like each other, right? This side says practice in math, in reading. People started to do meta-research on, okay, so if we compare these two forms of teaching, in math, in history, in physics, what actually works better? So, some controversy ahead. If you are easily scared by conspiracy theories, this is maybe the moment to leave this joke was funnier before the pandemic. It's probably better to leave the room now. Because if you compare explaining things, small things, and practicing a lot to having children figure out many things by themselves, research shows that this way is just a superior way of teaching, which isn't so surprising because this is a way of teaching you know from language, that you know from sports or music or math, depending on where you grow up in what age. So this is just the best way of teaching. And there's a really, really nice paper by a famous Dutch psychologist called Paul Kirchner, and the title of the paper, it's sort of a spoiler alert, it should go before it, is Why Minimal Guidance Doesn't Work. And this paper summarizes all sorts of other papers in different areas, different countries, different age groups that say, we ran the numbers and it's just quite effective if you just tell kids what they need to know and then have them practice that a lot. And there's one paper that I want to dive into a little bit more detail that Kirchner also covers in his paper. And that's this paper, The Use of Worked Examples for Problem Solving, by an Australian researcher called John Sweller. He compared two groups of children in math class. So two groups both got the same types of equations. So this type of equations that we also do here in high school, A is 4a plus 7, solve for A. One group just did these explanations. The other group got something called recipes, called worked examples. So like a recipe, it just said, oh, if you have something of this shape, what you can do is you can take this part and move it to the other side of the equal sign, but then a plus turns into a minus. So they just got recipes to solve the problems. This sounds wrong, right? You get an itch in your neck. Hey, why would you tell children how to solve problems? No, this is wrong. But this group did spectacularly better, the group with the recipes. You're like, of course they did better, right? Because you literally gave them the solutions. But they did really, really much better. They solved the problems in 20% of the time. So not 20% quicker, 20%, 1/5 of the time. And also, this is the most interesting finding of the paper, they also did better on new types of problems. So they did better on equations that did not have exactly this recipe shape. This is interesting. So we make them practice one thing, and then they actually get better at other related things. Having read all these things, I thought, this should probably also hold for programming, right? Maybe we should also try to figure out what does teaching like this look like in programming. And I started to be interested in how your brain works, not necessarily teaching, but more the biology of it almost. So I decided that I also wanted to know more about that. What happens in your brain if you read code, and more generically, what happens in your brain if you read. So we're going to do a little bit of neuroscience intro, specifically related to programming. What happens in your brain if you process information? It's more or less this. So this is your brain. This is information that comes into your brain. And what happens is that first, the information hits your short-term memory. And your short-term memory is very, very, very small. We've already known this since the 1950s, that your short-term memory can only hold between 5 and 9 elements. So it's really, in programming term, it is a tiny buffer, a mini buffer that hardly fits anything. And just to drive this point home, it's already late in the day, so we have some mandatory audience participation. We will do a little quiz. So I show you a sentence. It's a very short sentence, a 3-word sentence, and it's your goal to remember the sentence, just so you can wake up your short-term memory and see how small it actually is. So are you ready for this participation? Raise your hand if you're ready. You are ready. Here we go. So the sentence will be shown really briefly, like half a second. So you have to pay attention. Here we go. I said pay attention. Was this too hard for you? Is your short-term memory, see, it is really small. But you feel that I am cheating you, right? I am sort of playing not fair because I didn't explain everything. Yes, your short-term memory is really small, but if your short-term memory processes information, it actually collaborates with your working memory, which you can see as the processor of your brain, where information is processed and not just stored. Your working memory, in turn, again, collaborates with your long-term memory. And your long-term memory is usually if we say memory, we mean the long-term memory, where your memories are stored. And you can see your long-term memory a little bit like an angel on your shoulder that is jumping and giving you relevant information, like, oh, I know something about this topic. So whenever information goes to the working memory sort of asks the long-term memory, hey, buddy, do you know anything about this? And the long-term memory is like, sure, here is some information. All these 3 systems go into action if you are asked, for example, to memorize a very short 3-word sentence. So we'll do 2 more. And with these 2 extra examples that we will also do, you will see actually how big the role of your long-term memory is. So are you ready for another sentence? Here we go. It will be a bit easier. Shown equally briefly, though. Here we go. Still hard. But easier though, right? Because here was your long-term, if you're still awake, that is, it was your long-term memory. It was just, hey, I know these things. Hey, this is an A and a B and a C. Oh, not a C, a K. And then probably this is where it ended. But something was happening in your brain that certainly wasn't happening in the first sentence. We will do one more. And I will promise you that if you don't blink at the wrong moment, you will all be able to do the 3rd one. It is possible to memorize a short sentence in such a short period of time. Here we go. So you see, this is possible, right? It is possible to process cat lost cake if it's just shown very briefly, because these things come from your long-term memory. You are not remembering, oh, this is a C, this is a half a circle, and this is a circle with a squiggly, and this is a big cross. You just immediately look at the information, and your long-term memory is like, hey, I know these things. Cat, lost, cake. It is quite easy to do, because this is how big the role of the long-term memory is. It really very much helps in processing information. And if you're at this level, sort of break the rules starts making sense as an advice. If you're at a level in which you can look at something and you can immediately see more or less what it does, then you can start playing with words and exploring. But once you're not at this level, it just really doesn't make sense to do this exploratory type of learning. So cat lost cake is easier to process because these things chunks is what this is called in a technical term, are retrieved from your long-term memory. Knowing these three memory systems, we can now sort of direct our attention back at programming and think, okay, so we know there's something like a long-term memory and a short-term memory and a working memory. What happens with those three memory systems when we look at programs? These different memory systems are impacted differently. So we're going to look at three different programs that all do something differently to your brain. Here's a program in a programming language you probably don't know called APL, which stands for A Programming Language. In its defense, it's from the 1960s. There were not so many programming languages then. So it's like we are a programming language. It wasn't that there were hundreds like there are now. So if you have to tell me what this program does, this is hard because you probably don't know what this thing is. You know what twos are, and you can probably guess this n, it's probably a number, maybe it's an integer. So you have some sensible guesses, but your long-term memory is like, yeah, what is that t? So this is very much a long-term memory problem. And you can imagine if you are asked to solve this by figuring stuff out, good luck Googling for the letter T. And it's not even a T. If you look at it, it's actually a top symbol. Searching for information when you have so little hypothesis of what's even going on is probably not really going to be helpful. Probably going to go on a sort of a wild goose hunt, reading many interesting things about the origin of the letter T, maybe, if you're lucky. That is interesting to you, but it's really, really hard to find more information. So something like explore, make mistakes, break the rules, at this level is just really hard. The solution here is just your brain needs more information. It just needs to know more things. Here's another form of confusion. Here's a bit of Python that maybe is very easy for you to read or not. This really depends a bit on your prior knowledge. Because what we see here is something that's very Pythonic, very Python-y way to do things. It is a list comprehension. If you're familiar with this, you look at it and you're like, oh, this is a filter on age. Easy. If you're not familiar with it, even if you're familiar with programming, for example, if you come from something like C or Java that does not have this construction, these are many things in your short-term memory. This is like customer name, C dot first name for C in customers. Sort of here, between here and there, your memory is overloaded and you're like, well, I forgot what I read at the beginning of the sentence. So depending on your prior knowledge, this is a short-term memory issue. And it can be that this is for you Catalog's cake because it's so easy, because it's familiar, but it can also be confusing, right? Because also those three sentences, they were not inherently different. It's just that Catalog's cake is easy because you know the Dutch alphabet or the English alphabet. Here's another form of confusion that's different. This is a little bit of basic code, and I'm assuming that most of you will be familiar with the building blocks that we see here. Right? I guess you know what a for loop is, and you see that this is a variable, this is an integer, this is a loop, this is like this is where the loop ends, something is printed. So it's not necessarily your long-term memory that gets upset, because you know what happens here more or less. Your short-term memory may get full because there are many things to look at, but that's not even the biggest problem. The biggest problem is your working memory, your processor. Goes like, okay, I see every line, but what happens here, right? It's like you're reading a story that just doesn't make sense. Like, hey, a windmill goes to the baker to buy some bread. Like, what am I reading? This doesn't make, why is the windmill walking? How does he eat bread? Right? So it's confusing your processor. You're thinking about it, and it makes you confused. And if you would have this in an IDE or on paper, you would probably start to make notes. Like, oh, well, let's step through it. Let's take one value. This is 7, this is 3. So you start iterating, stepping through the code to figure out what's going on. This is a working memory issue. So your working memory is overloaded by this code. And there's no really easy solution for that. The only thing you can do is realize that your working memory is really full and offload some of the processing to paper, literal paper, or write some notes, write some documentation, write some comments, refactor the code, rename some variables, try to massage the code into being easier to process. So let's go back to this first sentence that you saw all the way in the beginning. Right? As I said, this sentence isn't inherently easier or harder than Catalog's cake. it is also just letters. It just happens to be letters I made up. But it's just, in my defense, other people made up letters also, right? It's not that I'm the first person to make up. All letters are made up by someone. So it's just that you don't know these letters. That's what makes them hard. And if you have to very deeply think about something because you don't have enough prior knowledge, this is a principle called cognitive load, cognitieve belasting in Dutch. Your brain works really hard, and sometimes you can almost physically feel it. Sometimes if you're programming or reading a newspaper, you're doing this, and you're like, oh, this is so hard. There's actually super cool research where they actually measure cognitive load by measuring the stress in your frowning muscles. That's the thing that people do to measure like how hard something is. So knowing about cognitive load and knowing that prior knowledge very much helps you to think, now we look at this result from Sweller and we think, oh, this makes sense, right? Because these people in the group that didn't get the recipes, they were so focused on the problem solving that they couldn't really remember, what am I doing, right? Why am I doing this? And they seemed happy. They seemed engaged. Oh, they're doing problem solving. This is fine. But they weren't really learning anything. Whereas this group was not so engaged. They were not very, very hard working, but that allowed them mental space to remember valuable tricks that are applicable in many different situations. That's something like, hey, if you have something on this side of the equal sign, you may always move it to the other side, but then a plus becomes a minus. That's a good trick. That's useful in many different types of equations. So because these kids were not working so hard, they had time to remember things. And this is sort of true also for the 3 sentences we did. Cat loves cake was easy to remember. You still remember it now. Probably if I call half of you tomorrow and say, what was the 3rd sentence? You're like, oh, cat loves cake. Like it is possible to remember that, whereas the other random letters, you can't even store it. So if I would actually ask you to remember that sentence, this would be a nice puzzle. Oh, nice, this is a puzzle. Fun, this will be fun, right? And then you just remember the sentence, but you're not really learning something because your brain is so busy with doing weird things. Knowing that now this result makes sense, but still it feels a bit counterintuitive because of the way we were raised in programming that, you know, but we're giving them the answers. That can't be right. No, they have to figure out the answers by themselves. It takes a while to shed these ideological feathers. And I think the nicest way to summarize this counterintuitive thing is knowing that you don't become an expert by doing expert things. It makes so much sense. Oh, we want children to be programmers, so they need to program. Oh, we want children to be good problem solvers, so we let them problem solve, let them solve problems. But it is way more effective to actually do small things related to what you want to do, rather than do the actual thing. If you're training for a marathon, what is a really good way to die, or at least not finish the marathon, is do a marathon every day, right? No one says, oh, you want to do a marathon? We do a marathon every day. No, you do related things. You do speed training. Maybe you do a bit of lifting for core strength. You do your marathon pace for 5K. You do 30K, but in a slower pace. There's so many places in which we've all come to terms with the idea that if you want to do a thing, you don't necessarily do that thing all the time. Whereas with programming, you say, oh, you want to learn programming? Well, we literally do programming every day. It's the only thing we do. We never do anything else. We do programming. It doesn't make so much sense. So what could we do instead if we wanted to teach programming, or in your case, if you wanted to learn programming? There's a really fantastic paper that I love from 1992, such a long time ago. It's called the Case for Case Studies in Pascal. This also dates the paper very nicely because Pascal is a very, very, very old programming language. Maybe you've never even seen it. This paper that sadly also got, last time I looked, 6 citations. Very sad. It's not my paper. Like, I was still, typing basic codes in 1992. So this is such an interesting paper because it was so much, I think, ahead of its time. Probably the reason that it didn't get much uptake then. They compared 3 groups of high schoolers. These were 16-year-old kids. The first group sort of got a traditional programming education. So they were asked to write a program, and then once they had finished, solved the problem correctly, then they got to read the expert version. So this is like traditional, you solve a problem, and then the next week the teacher says, oh, this is how you do it, this is my answer, or you look at an answer sheet. The second group was similar, so they also got to write their own code, also read expert code, but they also got extra explanation. So it wasn't that they just got the model solution, they also got explanation in the form of, oh, here I use a for loop instead of a while loop because such and such. Oh, here I introduce a function because this is the reason. First I tried this, didn't work, then I did that. The third group, interesting, only got to read the expert code and the explanation. They didn't do any programming. They were only reading source code and reading the corresponding explanation. And then the authors compared the performance of those three groups over a semester. So one group did no programming at all over the whole semester, and then they looked at the exam scores. So this first group was really what the teachers preferred. The teacher said, no, you can't have kids not program in programming class. This will be a disaster. But somehow the researchers said, oh, no, this is an experiment. I don't know how they did it. The paper doesn't say it. But they managed to convince the teacher to go with this. And then comparing the results, these two groups did the same and better than that group. So it doesn't even matter if you're writing code or not. Just reading code will give you the same exam scores as writing and reading code, and the scores will be better than people that were just writing code. Knowing what we know about cognitive load and about all the experiments that have been done in mathematics, this makes sense. Because these kids, maybe they were having fun, they were programming, they were like, oh, I miss a semicolon. Oh, now the semicolon is there. Yes, I am learning. But they were not actually learning because they were focused on the micro details of the problems. They weren't necessarily thinking about, oh, how do I structure code? This group was doing a lot better without even writing code. So all the effort also that many people in academia have put into auto-grader, so these are tools where you can submit source code and then it checks if it's correct. This is all for nothing because it doesn't even matter. You might as well just read code. This lowers the cognitive load and then probably makes sure that you remember things better. So before we go to Q&A, I will answer one question that people often ask at the end of this lecture. Once, this was also before the pandemic, I gave this lecture in the US, and then a guy came up to me. They're often guys, came very close, this was before the pandemic, very close, points at me with his finger, like this, so very close to my nose, points at me and said, "You're making it look like school! School! Oh, this is terrible. No, we shouldn't make programming like school because it should be fun, right? Remember, the most important thing is fun. This does not sound fun. You're ruining the fun, you little witch. But I have science on my side. It doesn't actually matter that much if people have fun, right? I trained for a marathon. Do you think that's fun? Do you think it's fun to wake up at 6 a.m. and go running for 30K? Right? Why is fun important? Right? We know that if you're learning something, if you want to get better at something, this will be hard, right? The reason that you get up and go train in the morning is because you're seeing that it makes you quicker, that it has an effect. And that is not just true for physical exercise. This is also true for school subjects. So we think that interest will lead to skill, right? That if kids are just motivated, if they're having fun, if they want to learn, that they will learn. But that isn't necessarily true. There is a connection between motivation and skill, but the direction is not so much this way as it is the other way. So it's more that skill impacts motivation than that motivation impacts skill. If you see that these small exercises make you better, like, oh, I learned a little thing, oh, now I know this, then that will give you motivation. And then you can get to sort of this upwards stream where you make a little bit of progress, you get motivated to make more progress. But the other thing is true as well. You can have a little bit of motivation, but then if you're not learning anything, or if you're Googling the letter T for 3 hours, you're like, well, I wanted to learn programming, but I think I'll be a plumber. That also pays well. So that's actually also science. There's a nice paper from an economist at Erasmus University that has looked at the interest of the role of interest in learning, and this is also a meta study, so looking at many different papers, and they show that these things influence each other, but that skill influences motivation way more than the other way around. If you want to know more, well, we have some time for Q&A, but also I wrote a book on this. So as I said, my career was entirely derailed. My boss was like, hey, are you doing programming languages still? I'm like, no, I'm reading the whole curriculum of the PABO. Check back 3 years. But ultimately it led to something because I actually wrote a book on this. So if you want to read it, it's called The Programmer's Brain, and it details in a lot more depth, of course, than we cover today, the things that we talked about. So cognitive load and the 3 memory systems is sort of chapter 1, chapter 2, but it goes into a lot of detail about also different activities. What does your brain do if you're programming? Sometimes you're searching for information. Sometimes you are figuring stuff out, looking for something. So that is in my book, The Programmer's Brain. If you want to know more about what I do, I'm on Twitter. Are you people still on Twitter? Probably not. I will be there until Elon Musk buys the thing. So I'm on Twitter, but I also have an old-fashioned website, Felienne.com. If you want to buy the book, you can go to felienne.com/book. One more thing, if you think, oh, I like listening to that lady, I would like to listen to that lady for hours and hours and hours more for free while I commute or do the dishes. I have a podcast as well. It's called Software Engineering Radio. It's on Spotify and iTunes. It's an interview-based podcast where we interview people from software engineering, a very broad range of topics. So sometimes it's about databases, but it can also be about soft skills like how to do a job interview if you're a programmer. So if you like listening to me, you might want to check out my podcast as well. And with that, we can go to Q&A.
Indeed. Okay, let's give a round of applause. As usual, the people in the audience, I'm going to throw the catch box. And the people that are watching us from home, please use this Slido, okay? So you go to slido.com and then you choose the event, #CodamX, with a big capital C and capital X. Yes. Okay, let's start over here.
Yes, it just boggles my mind that like just reading code and never actually touching like a computer just is more effective than actually writing code, and like, but I don't understand. I don't understand.
Yeah, so I understand because it takes a sort of a while to internalize these things, but I think it does make sense if you look at it from how busy your brain is. I mean, I have programmed, where I was really just figuring out the syntax. And then the next day I come back to this code, maybe you have a similar experience, and you look at it and you're like, what idiot wrote this? It was me yesterday, right? So this is, I think, cognitive load in action. Sometimes you are so busy with something that you are not remembering because your brain is so full. I do think it makes sense. And there's very interesting research, like I wanted to include more research, really interesting research that has looked at first-year programmers in Java, and they've shown that half of the programs that first-year students submit have a syntax error, half. And then for the worst student, that can go up to 75%. So imagine that 3 in 4 of your programs are not compiling. That is not productive failure, right? This is not like, oh, I made a mistake. This is interesting, fun. I fixed the mistake. Then there's another mistake and another mistake. You can imagine in such a scenario, you are not learning. Also, one other answer is there's something called the curse of knowledge, which is once you know something, it gets really, really hard to not know the thing and to understand that there exist people that do not know this thing yet. So at one point, for us, maybe this is not the most effective way because we already have so much knowledge. But if you really have no clue what anything is doing, then it can make sense. And it's actually interesting because I think more people now are learning in that way than they were when I was a kid, because there's so many YouTube tutorials and Twitch streams where people also explain, right? It's not just typing, they also say, oh, I do this, I do this, I do this, which is sort of similar and probably also quite effective. But yeah, no, I understand that you see this research and you're, yeah, this cannot be right. But give it a bit of time, like read my book and check back in a year and maybe you change your mind.
Thank you.
I thought it was very interesting your point about that it doesn't have to be fun, which is, I think, slightly misleading, but I suppose you mean that it doesn't have to be exploratory, kind of fun. But does the research also look into the retention of people with the other approach? Like how many students does it retain in comparison to the exploratory fun approach?
Yeah, so this is a great question. Sounds like I'm marketing my book, but there's a whole chapter about like remembering things. So research also shows that if you revisit knowledge often, that then it will stick in your brain better. So if I call you back in 3 days and say, hey, cat loves cake, remember? And you're like, who's this? Why is this weird lady calling me? But if I do this for a few weeks and you do not block my phone number, then ultimately you will remember the sentence forever. So revisiting information is really important. And then again, it is also a bit about effectiveness. So you can revisit information about programming by programming, but you could also revisit this information by simply reading it or practicing with flashcards. The key for long-term retention, we know from research, is really repetitive exposure over a period of time. That's more important than the form, that you just, like we told, took these exams in schools where like the day before you cram everything and then you get a passing grade and the day after you don't remember. So that's really the key to retention, is long-term repeated exposure.
But I also meant like retention of people in, say, the classes or whatever.
Oh, like do people drop out? Yes, that's actually also very interesting. And that's very, many things are interesting. It very much depends on your self-consciousness, your self-efficacy. Like how sure are you that you want to do something? So we know from research that if people really want to become, let's say, a programmer, and then they fail a lot, it doesn't affect them. Sadly, we know this is very true for boys, way more true for boys than it is for girls. So boys can want to do something, and they fail all the time. And you ask them, hey, how are you doing? And then they're like, I'm doing fine. Whereas we know that girls, because maybe they already have lower self-efficacy, because sort of society says, hey, programming is maybe not for you. If they fail often, and they do very exploratory work, they tend to get into this downward spiral where they're like, oh, I make mistakes. Well, maybe my dad was right. Maybe programming isn't for girls. And then it sort of never comes back. So with retention in a certain topic, it really, really also matters where you grow up and what beliefs you have about yourself and how sure you are you want to be a programmer.
Well, thank you for your presentation, or masterclass, I should say. So my question really is, so first you were exploratory, oh, let's find this out, let's type this 2,000 times and find mistakes, compiling mistakes. But now, how does your programming day look like in the sense of not working, but to gain more knowledge?
So if I'm learning myself, you mean? Yeah, so that really depends. I think one of the things, so two things I learned about learning myself is to really give myself time. So I was learning a new programming language called Rust recently, which is really different from everything I've ever done before. I don't know yet. It's complicated. So I think like 5 years ago, I would have looked at Rust and I was like, okay, I'm 40, I'm too old to learn. I will go back to Python, which I know. So I think one of the things that as a result now I think, okay, I can do this. You know, over time, I know what I'm experiencing now is a lot of cognitive load. This will be fine. So that I think is one effect on me. One other thing is really, I know, especially with something like Rust, where I have some prior knowledge, but also I have many knowledge gaps, I have to be very specific about the things I want to know. Hey, what are the strange triangle thingies? Why is there a quote, an opening quote, and not a closing quote? My Python JavaScript brain goes like, where's the closing quote, right? So I have to suppress this because it looks like a string to me. My brain goes like, I know this thing, it is a string. Oh, it's not. This is a borrow. So you get aware of what the things are that your prior knowledge, your long-term memory ain't just like trying to give you, and where that will be helpful. If I see a function in Rust, I'm like, oh, this looks like a function, right? Here my prior knowledge will be helpful, but here my prior knowledge really needs some gaps. So I've also gotten better at understanding my own misunderstanding. It's a great question.
Sorry, but maybe I should be more specific. So if I open my laptop, first thing I do is like something like touch typing exercises. And then usually I make like a simple coding exercise and I have some sort of system to learn coding. And I'm wondering if you're teaching, what is the method really that you employ?
Yeah, so various different things, but it is very much focused on a lot of practice. So a lot of small exercises. So if that's something you're doing, that's already okay. One of the things we're also doing is instead of testing kids or students, they don't have to submit programs. We give them little quizzes. So we give them a program and then it has 3 gaps. And then with a multiple choice question, you just say, oh, this keyword goes there, this keyword goes there, this keyword goes there. That is also a really good way to test knowledge. There's an interesting technique called Parsons problems, which is a programming exercise where instead of writing all the code yourself, you simply have to rearrange the lines in the right order. Research also shows that that is actually as effective in testing student knowledge as free programming is. So we tend to do these type of exercises that are lower cognitive load because it's easier to rearrange lines of code than it is to type them, which hopefully then will lead to better retention.
Do you have an example for that software?
Yes, if you just Google Parsons problems, there are different types of libraries in various languages that you can use.
Wow, thank you.
I would like to be the voice of the people from home because we have a bunch of questions over here. So I would like to read the one question. Yeah, oh, fantastic.
Nice.
Would you like to repeat it or shall I read it? No, but you have to use the microphone, otherwise the people from home cannot hear you. Yeah? Okay, fantastic.
So, yeah, my question was, how do you know if the students are actually understanding things and not just reproducing what they've been shown? Because I remember in high school, I had a lot of these math exercises. The teacher showed how to solve them, and I just kind of reproduced that. But then on the exam, it was a little bit harder, and I didn't have a clue what to do. And I'm thinking, if you want to break through that barrier, aren't you in the end always ending up at the exploration, like the exploration path? Because you can't like always reproduce just what you've been shown.
Yeah, so there's another chapter in my book about this. But there are different types of knowledge. Some knowledge is actually good if students can reproduce it, right? If I wake you up in the middle of the night and say, how do you declare a function in Python? It's just nice if you know this, because then if you need it in reality, it doesn't take you any energy. So for some types of knowledge, I don't mind it if students are just repeating what I say. If they repeat at the end of a line in Python, it should be a colon, and in JavaScript, it's a semicolon. I like them to know this knowledge by heart. So that's not always a problem. It is true what you say, sometimes students replicate something, but then it is also very important to make sure that they have the right path. So if you just reproduce exercises, and for example, you don't look at why is something in a certain way, like this nice tree-group experiment did, then you might miss application knowledge, right? You don't know when to apply something, but that is also something you can practice. And the nice thing is that you could also practice that at speed with low cognitive load. For example, one of the exercises I also do with high schoolers that I teach now, I give them a problem, like you have to reverse a linked list or you have to print all prime numbers or something like that. And I just tell them, what 3 programming ingredients would you use? What 3 things would you use instead of write the whole program? Then they're quickly practicing, applying their knowledge, but it goes very effectively because they don't worry about syntax, they just worry about what are the concepts. So then now we're practicing the application of certain knowledge, and then hopefully in the exam or in the real life, you get a combination of, hey, I know certain things and I know how to apply something. That is also a model that you can practice the application. It's very important that you also practice this, but then again, that doesn't necessarily have to be practiced in an exploratory way either. I mean, it's not that I'm saying never let people explore anything. It's just that if you're doing it, be aware that any type of exploration also gives you extra cognitive load. So you have to be sort of precise about when you're doing it. And certainly it shouldn't be the only way. But yes, it's definitely true that there's always something. This is also what sometimes makes programming fun, is figuring something out, how to do it by yourself, but in a sort of limited scope, where it's also clear that you're stuck for you and clear for the teacher that you're stuck. It doesn't look like you're making progress, but actually you have 500 Stack Overflow tabs open. And, I'm making progress, but you're not making progress. Then you're sort of in a danger zone where you might lose motivation and you're not effectively learning.
Actually, I would like to take another question, which is very relevant towards the students that are inside the room, as well as the people from home. And I see people from Malaga joining and Rio.
Cool.
And yeah, so
Awesome.
thank you for following us. So the question is, how does your explanation compares to the 42 learning method? It looks like 42 is closer to do not give them any basic information, let them figure it out. We already discussed this, with our Bocal staff, but maybe for the students, you can make an explanation as well.
Yeah, so is the 42 learning method, is this your learning method? Yes. Yes, so I think it is true that I very much appreciate what Codam is doing. So I don't want to say, oh, you're doing it wrong, right? Wrong. I don't want to say that, but right? But I had this super nice discussion with one of your team members. I don't know which of I don't remember the name of this team member, but there are really good reasons to criticize schools. There are really good reasons to criticize school systems, including the Dutch school system. So I very much appreciated that you're trying to sort of fix or make a home for people that might not fit into this traditional school system for various reasons. However, there are things that also school does okay. So you have to be aware, I think, to not do things because they look like school, because some things that schools do, given despite all their flaws, can also be helpful, like giving people the basic blocks and having them sometimes in moderation practice the building blocks. So I just think it needs to be a mix. And it's good that in math and in language we have these two sides, and some people are a bit more here, teachers and students, and some people are a bit more here. And it just seems that in programming we have been very much dominated, so this side I should lean, very much dominated by this exploratory side that has its benefits, but you also have to make sure, like, it's literally called a piscine, right? There is a risk of drowning when you drop people in a piscine. On the other side, you would say, yeah, school is boring, you make people lie on the ground and they swim like this. That's also not helpful. Both are true, but you need a bit of everything, I think.
Actually, I have 3. I don't know if that's too many. I can limit it.
Let's take another 5 minutes. Okay?
Yeah. I can do one if it's too much. Yeah. Yeah, true. I might do that. Okay, in that case, yeah, choosing is hard. But talking about the balance between the exploratory part and the basics, like learning what the building blocks are, and the different school systems and stuff like that. I would say there are problems with the old school system. I think that's pretty easy. That's hard to deny. As an expert of education and programming, what would you say the biggest problem with education is right now, of traditional education?
Like programming education or generic programming education?
Yeah, you can do in general as well, but just you can do either.
Yeah, so well, let's do programming education because I'm an expert on that. So I think apart from how we teach, I also think the emphasis on why is very important. So that thing I showed about programming is fun, I think that inhibits some people to even start programming education, and I'm not even talking about finishing. And we know that girls tend to care a lot about the environment around them. And they want to make the world a better place, a bit more likely than boys are at the age where they're choosing programming. Right? So if you say, hey, this will be fun, and then what do we show them? Hey, print, hello world. Like, if you want to be a programmer, that's fine. And then the next exercise is, let's print all the prime numbers under 5,000. It doesn't show why programming has value, right? And it also, these type of exercises that are very often focused on math, oh, here's a maze and we have to find the best route through the maze. It doesn't show what a career in programming looks like. It doesn't say, hey, if you don't like programming, you don't have to like programming. I don't care if you like programming. If you're in my programming class because you want to make 100,000 euros a year, by all means, be in my programming class, right? We know that kids from lower socioeconomic families, for good reasons, tend to really care about making money. So if you say, hey, this is a super cool programming course and we will do prime number printing and maze searching, then a kid that wants to make money doesn't think this is a good career. Maybe they go into economy or management, which is also fine. But it's a pity if those reasons aren't shown up front. And I think the fact that in the Netherlands, at least, most of the computer science teachers are old white men that very much like puzzling aspects of programming for selection bias reasons, they tend to pick up the same type of kids. And so I now also teach in a high school, and I am even at risk of this, because then I have a few, they are all boys that are very excited. You know, they come into my programming class and they're like, oh, teacher, last night we broke the internet at home because we were messing with the router. Then, you know, I am also get excited. I'm like, oh, when I was 14, I was also breaking computers. This is totally normal behavior, children. So it's really hard to not connect with these type of kids, whereas you want to be a teacher for everyone. And I think the sad reality that we have 9% female CS students in university in this whole country is... not here. This is fantastic, right? I said I love Codam, but I think there are various reasons for that. There are reasons that, you know, parents, I want to be gender inclusive, so I want to say parents and not dads, often dads, say that, oh, programming is for boys, right? And they bring their sons to programming clubs and not their daughters. That is an aspect of it, the way we teach, but also the things we say about programming, like why is this a good career choice? It's always also very much focused on fun, on puzzling, and on solving silly problems like reversing a linked list. Like, who cares about that? Like, so that I think that's the biggest problem we have in CS education, but that's like a huge problem. That will not be. So when I was in university, in my year, there were like 2 girls out of 150 boys when I was studying computer science, and I thought, oh, but this is like, it's just a problem of the time, right? When I'm 40, this will... this will not, no, it's a sad reality. Like, if I go on my pension in 25 years, it will still not be finished. This will not be solved in this country. So to end on a happy note.
Thank you so much, Felienne. Guys, let's give a round of applause to Felienne. It's a pity we didn't manage to take all the questions from the people from home, but you guys that are just right here, if you want to stay for another 5 minutes and connect to Felienne, she's still here around. So please join her and yeah, have a great day. You know, I don't want to keep you waiting from your other stuff to do. You know, so yeah, cheers.